Hello and welcome to podcast.init, the podcast about Python and the people who make it great. I would like to thank everyone who supports the show on Patreon. Your contributions help to make the show sustainable. When you're ready to launch your next project, you'll need somewhere to deploy it, so you should check out Linode at podcastinit.com/Linode and get a $20 credit to try out their fast and reliable Linux virtual servers for running your app. And now you can deliver your work to your users even faster with the newly upgraded 200 gigabit network in all of their data centers. If you're tired of cobbling together your deployment pipeline, then it's time to try out GoCD, the open source continuous delivery platform built by the people at ThoughtWorks who wrote the book about it. With GoCD, you get complete visibility into the lifecycle of your software from one location. To download it now, go to podcastinit.com/GoCD. Professional support and enterprise plugins are available for added peace of mind. You can visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. And if you have any questions, comments, or suggestions, I would love to hear them. You can reach me on Twitter at podcastinit or email me at hosts@podcastinit.com. To help other people find the show, please leave a review on iTunes or Google Play Music, tell your friends and coworkers, and share it on social media. Your host, as usual, is Tobias Macey, and today I'm interviewing John Bywater about event sourcing, an architectural approach to make your data layer easier to scale and maintain. So, John, could you please introduce yourself?
Hi, my name's John Bywater. I'm a software developer in London. I graduated from Oxford Engineering and did robot development for a while, and then got into consulting in Cambridge and eventually started doing my own thing. And been involved in various open source projects, and one of which is the event sourcing project, which we're talking about today.
And do you remember how you first got introduced to Python?
Yes, I do. In about 2004, I met a guy called Rufus Pollock who was starting the Open Knowledge Foundation, and he wanted to develop some tools in Python. And the first thing we built was a project hosting system that integrated different version control systems, such as Subversion and Git, and different trackers, such as Track and Redmine, other common tools, such as wikis and blogs, so users could start projects, add services such as repository and tracker, and add members who would have access to project services. Unfortunately, shortly after we finished that project, GitHub became very popular and we all started using GitHub. Eventually we abandoned the project hosting project. The second project in Python was called CCAN, which is more successful. CCAN is now being used around the world to publish open data. For example, the US government's open data website, data.gov, uses CCAN. We factored out from these projects a library that followed the patterns of enterprise application architecture, and I used this library for several other projects. Eventually, disappointingly to my frustration, the domain model library became increasingly difficult to develop for reasons that I didn't understand at the time. I later realised the trouble I was hitting on was known as the impedance object-oriented software and relational databases. There's a long Wikipedia page about it. I had wanted to arrive at something general and complete, but it became increasingly exhausting and complicated. Firstly, there were temporal properties, temporal objects. There were differences between object graphs that seemed to be like branches that could be merged. I worked on that for a bit. I was always able to get something working, but then I would think of something else that it couldn't do, and these subsequent thoughts never seemed to follow on very well from each other. I could tell it wasn't going very well, and after spending a lot of time on it, I eventually abandoned the project. When I look back, it was obvious from the number of patterns from those different kinds, patterns of enterprise application architecture, that something wasn't completely resolved. Anyway, it was a big problem that I didn't understand at the time, and event sourcing eventually appeared as a solution.
And can you describe briefly what event sourcing is and some of the benefits that it provides to people who are using it?
One definition of event sourcing suggests that the state of an event-sourced application is determined by a sequence of events. Another definition has event sourcing as a persistence mechanism for domain-driven design. It is common for the state of a software application to be distributed or partitioned across a set of entities or aggregates in a domain model. So the application sequence of events is really a set of sequences, one for each entity or aggregate. It's a different approach. The benefits of event sourcing lies in the sympathy between what you're coding in an event sourcing system, which are the events, and the domain, which is inherently event-based, in that the interesting thing in any domain is what happens, and what happens leads to a state of affairs, which could be taken as the object model but it's the events which lead to those states of affairs which I feel are more interesting. And the benefit of event sourcing is that it allows you to code against what happens in the domain. I mean, that's not quite strictly true, because there we're talking about domain events, and the domain events don't necessarily need to be persisted. You could have the domain events changing objects and then saving those objects. But the event sourcing thing gives an economy of scope between coding an event-based system and persisting the state of that system, because you can simply persist the events which are being published, and you don't have to do anything else.
And from my understanding of reading about the sort of architectural pattern of event sourcing is that it also allows for fixing sort of logical errors in the way that you're processing the events, such that if you find a bug in your system and you want to resolve the way in which you are interpreting it, you can just replay those series of events to create a new view on the data, while the actual data itself, the individual events, remain immutable. As well as, one of the other benefits of the overall approach is that it can potentially give you the ability to time travel in your data, so that rather than saying, as a for instance, what is this person's address today, you can say, what was their address 5 years ago, where in a traditional RDBMS system or relational database system, you can only ask for the present state of information unless you explicitly create a new table of the history of the changes to that person's address or state.
Indeed, and at that point we can't say that the advantage of event sourcing is that you can have a history, because you can have a history with other systems too. The advantage of event sourcing lies in the primacy of the events in the system, and the avoidance of the problems that you encounter when you make the state of affairs primary and then the events secondary to that.
So you wrote a library to implement the event sourcing pattern in Python. So I'm wondering if you can describe a bit about the library itself and what your reasoning was for starting work on it.
Sure. The library provides mechanisms useful in event-sourced applications. A way for events to be stored and retrieved, a way for events to be replayed to obtain the current state. In addition, there are a few classes for making an event-sourced application, such as domain event and domain entity, aggregate, repository, persistence policy, application, and so on. I started the project because it seemed that with a good library, it would be much easier to suggest doing things with event sourcing. You don't have to say, it's a good idea, but I would need to delay the start of your project by a couple of weeks so I can write a little framework that will save us loads of time. You can just say, there's a library here, we can start to use it. Also, I wanted something I could add to over time, one good piece of open source code, not a number of different little frameworks that I had to leave behind when I changed job.
And so going back to the ideas of when somebody might want to implement event sourcing, what are some of the reasons that they might not want to include that in their approach for their persistence layer of the application?
It's a good question. To think about when someone might not want to do it, let's look at what brings us to event sourcing and see what isn't included in that. For me, this term persistence layer comes from the layered architecture, which when I started work was known as n-tiered architecture, often with n equals 2, so that you have a presentation layer and a database layer. Before the web and mobile, many applications were developed by dragging widgets onto views and hooking them up to database queries. The domain model was in the database schema. Interleaving a domain model layer between the presentation layer and the persistence layer was hard work. It's hard to think how event sourcing could have figured in these applications. But as soon as there are different presentation technologies, common stuff, let's say the business logic, needs to be pushed down below the presentation layer so it isn't duplicated in each interface. We can put business logic in the database, but then it's hard to maintain. Writing complicated SQL is not really object-oriented software development, so we don't get to benefit from that genre. Unit testing, refactoring, the agile approach, and so on don't really apply very well. So we're looking to put it in the middle between the presentation and the persistence layer so we can write proper software. It became known as the domain layer because it, more than any other of the layers, reflects the domain supported by the application. So now we've got objects in the presentation layer and objects in the domain layer, but also a relational database that echoes the names of the domain layer with tables, named after the domain object classes, and columns named after attributes, and so on. It's all quite promising at first, and it works well for lots of things, but it brings us to the impedance mismatch I mentioned earlier. It brings us to all sorts of different kinds of energy-draining complications. Event sourcing finally purges the database of all traces of the domain layer. The database is used to store sequences of items. The application happens to store sequences of domain events, but the database doesn't know that. The database just has sequences of items. Now we don't have any problems. We have objects in all three layers. We can develop software without getting caught up with infrastructure. All we need to do is return to the domain and ask what happens. Event storming is the practice that's developed in that particular corner. It's all very easy, but some people have only read the Django book, and event sourcing isn't in the Django book, so you've got to watch out. If you ask people casually if they've heard of event sourcing, almost everybody says no. It's very common to find a situation where people are comfortable with the n-tiered architecture as it appears in its half-baked form with an ORM and the impedance mismatch. But hey, you might be able to live with the impedance mismatch. It will drain your energy, but you might be able to live with that. It can seem more effort to understand event sourcing, to develop the skills to develop a well-factored, standalone, event-sourced domain model, and to habituate on the software development process that is sympathetic to the architecture, that understands what it is producing above all. That is a ubiquitous language that hangs off the names of the domain events. In this situation, in a situation where there aren't really the skills to do event sourcing, it might not be desirable to try. But it's quite hard to think of a domain of human activity that isn't essentially constituted by what happens, with the resulting state of affairs deriving from these events. So we get to the equality nature equals history. So if you're asking about a persistence layer, we're already talking about a layered architecture which comes from the world of developing the scope of a system to support the scope of a process, from working to support a domain of human activity. And since all domains of human activity are constituted by the events which take place, so it's always going to be natural when supporting those domains to name events, to cluster them into aggregates that respond to commands by doing some work and publishing the results of an event, and respond to those events according to a policy that causes further commands. So it's quite hard to think of a domain that wouldn't be susceptible to a domain event-oriented approach, but it's quite easy to think of a situation where the skills just don't reach that far. And in such a circumstance, it might be a good reason not to implement event sourcing.
And throughout this conversation, we've been referring a lot to the sort of domain of the application, and from reading through the documentation that you have for the project and from past readings, the reason for using that particular terminology is because of the fact that event sourcing was sort of originated from the area of domain-driven design. So I'm just wondering if you can take a brief aside and explain a bit about what you mean when you're referring to the domain of the application and how that relates to domain-driven design.
Well, when I think about the domain of an application, we're talking about something that's more general than a particular site. So you're trying to identify the kind of work that takes place that's supported by the software. And the approach that I take is that the software is something that's automating the work to a greater or lesser extent. So there's a scope of the work, and then there's an extent to which that scope of that work is covered by a system. So there's a scope of a system which is less than the scope of the work, but the system tries to automate to some extent the work. And when we're looking to understand the work, we're looking at the domain and not a particular site, so that we can maybe find things that tend to happen in that kind of work. And it's bounded by an event and a response. So if we're thinking about a process, the way I think about a domain anyway, it's a process that's basically a collection of event responses that work towards a goal. So a process isn't, for example, a fire engine charging around town aimlessly. A process is that the fire station responds to a call, and then they charge around town with the goal of putting out the fire. So it's the triggering event and the outcome which is desired, which is worked towards, which constitutes a process, and those can be kind of stacked up, and a domain is many of those triads: event, response, goal, triads. And then the software system is kind of picking out things within that work which would be useful to automate, useful supports for that process. So, for example, it's quite hard to make a call to fire station if there's no telephone. So a telephone would be useful so you don't have to walk there. And, a tracking system so you know all the different fires that are taking place in town, so you can see which ones you successfully put out or not, and redirect firemen to the ones which aren't out, are still burning. And, then you can develop support for fire stations as a domain rather than the particular fire station at the end of your road with all its idiosyncrasies, which they may usefully depart from, or perhaps not. But in any case, the domain's the place in which the work happens, and that work can take place in different sites in different ways, but you're aiming for the more general work rather than the particular site.
And given that you're storing a record for each event that occurs on one of those domain objects, I'm wondering how that affects the amount of storage necessary to support an application that's using the event sourcing pattern.
Yeah, it's a good question. If the object changes lots of times, then will be more data in an event sourcing system than in a system where the object is stored as a single record that's updated. But often people like to save a copy of it each time it's changed, so that attributes that aren't changed are stored over and over again. In this case, an event sourcing system would require less storage. Another aspect I've noticed is that even when people are not comfortable coding domain events and would rather have a database schema that is reminiscent, if not reflective, of the domain model, they like to write lots of log messages that report on what is happening, so you know a record was created or it was updated and so on. When scaling a system, it can happen that logging all these messages, which really trace the domain events, but in a way that minimizes their value, can require lots of storage, especially when loaded into a search engine, so they can be queried, which leads to the need to log each message to include the ID of the event, the timestamp, and so on. So you can pick out the log messages which pertain to a particular user action, and thereby hope to identify what the system you developed does. And if something can't be found, we still aren't sure whether it happened that the log message didn't come through, and you can spend a lot of time investigating log messages when really all you're trying to do is find out what's happening in your system and you haven't coded that directly as a domain event. Anyway, instead of all of that junk, the software can just publish events. The events can be stored, and the stored events can be queried. And if you're doing that, then although it takes up more memory than if you're just simply updating one record, often you don't just stop at updating one record. You want to keep a trace of what's happening. And all of the other ways of doing it often can use more storage than you actually need simply to store the events.
Yeah, your point about using log messages as a half measure of tracking the events in a system is definitely very sort of poignant, because I've spent far too much of my time trying to trace through log messages to understand what was actually happening at different steps of the application.
Yeah, we all do. It's And the thing that makes me smile is that the data that you're putting into these log messages ends up being almost identical to the things which are happening in the domain events. It's just that if people aren't used to dealing with the domain events directly, then you look around to grasp onto other things, and you resort to log-d, Kibana, and so on.
And to your point too about sort of duplicating the information that is contained in the overall state of the object, when all you really care about for a particular event is maybe the different attributes that actually changed. Are there ways that you can sort of reduce the overall amount of data storage by just storing the diff and then using that as a means of constructing the current state of the object by referencing from the sort of root node of the when the object was first created, and then replaying those diffs against each other to reconstruct the current state?
Yes, you can do that. I mean, that's something that I tried to do maybe 6 or 7 years ago, and it just becomes increasingly difficult, because what's the diff of a many to many? What's the diff between a many to many between two temporal objects? It just becomes harder and harder to actually make it happen in a general way. And if it's not general, it's broken, because you're trying to do something and it just doesn't support that particular thing. So,
Yeah, so it sort of becomes the time-space trade-off, where you're trading the overall amount of storage space for the amount of computational time that's necessary to be able to construct the current state of that object.
Indeed.
And What is the overall impact on performance and latency from an end user perspective when the application is using event sourcing? Because from my understanding, if you're, I guess it depends on the way that it's implemented, but when you're storing the individual events and then you want to be able to report back to the user what the value is that they were trying to retrieve, or what the current state of the overall system is, you would potentially need to replay those events to create a view on the overall system at a given point in time. So does that increase the overall sort of latency in terms of confirming a commit to the database?
Yeah, it's a difficult question. It's difficult to compare to two different things that aren't entirely fixed. But the way I'd answer this question is that, if the question is what is the impact on performance and latency from an end user perspective when the application is using event sourcing to render the current state of the system, I would say that obtaining the current state of the system by replaying all events is likely to take longer than reading records that record directly that current state. However, in practice, the current state of a system is rendered in views that are developed to support particular uses. If the data required in a view is stored in a way that requires very little computation to retrieve, then the view will perform faster than if the data required in a view is stored in a way that takes lots of effort to assemble. So if the domain model is persisted into tables using an ORM, then simple lists of objects of the same type will work well, but pulling a more complex report across different tables will take longer. Similarly, it will take a long time to go through all events in an application to find anything at all, which is why in an event-sourced application it is necessary to have view data that is updated by the events. If the view data is prepared, then it would be strange to store the view data in a way that requires a lot of work to assemble when rendering the view. So we can expect the views of an event-sourced application to have good performance by virtue of their dedicated purpose. But if we return to the application which has lots of tables to store domain objects, it appears as a big disappointment that the objects aren't already naturally a good fit for the views, and we don't know whether to spend time optimizing the queries, reworking the domain model, or building a dedicated view model and figuring out how to catch all the differences that result from model changes. This is relatively hard work, and if there isn't enough time, and the application can be shipped with a slow view, then it will be. That's why it's more likely with an event-sourced system that the views will be fast. There aren't any complications that divert developer energy away from the task of developing a view that performs quickly.
And sort of taking a concrete example of, for instance, a PostgreSQL database where you're writing the event into one set of tables, the sequence of events, and then you want to be able to report on current state, would the sort of best practice suggest that you would just write the events into that table, that sequence table, and then create a database view that just queries the most recent values? Or would you, for instance, write the event into that sequence table and then also update a canonical record of the current state in a separate table and then report from that separate table?
Well, there's choices, aren't there? You have to decide what you're trying to do and why. I think the nice thing with an event source system is that you can introduce views later. So you can decide later what views you want, and then initialize them by replaying all the events in the system, which will take a while. But then once they're initialized, update them from events that continue to happen. In the Postgres example, you'd have to decide whether you wanted the report to be something which you can generate quickly or not. If it's not something that you need to be able to generate quickly and you can run it over a weekend by going through all the events, then you can do that. But if it's something that you want on a push of a button, it kind of needs to be sitting there so that you want to keep it updated as things in the system happen. And obviously there's lots of choices around that as well. But, there's nothing in event sourcing which forces you to have slow views, and there's nothing that stops you from going through all the events every time you want to find out anything at all. It's a matter of using the available developer energy to optimize the system that you're developing over time. And the thing with views is that you have to decide what you want to see, and event storming helps to do this, because if you want to decide which command to issue, you need to look at some data. So you get the little green post-it notes showing views, and that's what you need to see before you make the decision about something. You want to see what the state of affairs with pertinent objects is, and you want a view to do that. So that view needs to be there, and you need to be able to see it quickly. So you need to keep it updated. Unless it's a slow report that gets generated over the weekend or something like that.
I could definitely see the case where using event sourcing for a reporting system would be useful, where you can, like you said, just run it as a batch job that can take however much time is necessary. And conversely, for a transactional system in a typical CRUD web application where somebody wants to write something and then be immediately able to retrieve it, you could potentially use something like a database trigger that will update a separate table with the current state based on any event records that get written to the sequence table.
Indeed. Or you could have an application log that follows all of the events that are happening in the application, and have a notification log, and archived logs like Vernon describes in his Implementing Domain-Driven Design book in the Appendix A, I think. Is it Appendix A in that book? There's a whole discussion. I mean, I've implemented some of this in the event sourcing library, but if you want one context to kind of follow another context that it depends on, then you want the depending context to pull notifications, and it needs to be able to see when one of those notifications is missing, so it needs to be integer sequenced. That's how, and then you can bracket those up into pages of events, 1 to 20, 21 to 40, and so on. And then those are very suitable for caching in HTTP world and scaling. And then you can have an event notification system over the top of that, which tells the subsequent, the downstream components when something's happened, so then they can catch up either by using the notification directly or by then pulling from the notification log the things that it doesn't have.
And bringing us, specifically to the work that you've done with the event sourcing library, I'm wondering if you can share what the internal architecture and design of the project looks like and how that has evolved over time as you've continued to work on it.
Yeah, so it follows layered architecture. So the top level folders are application, infrastructure, domain, interfaces. So it follows layered architecture. There's a domain layer, an infrastructure layer, an application layer, and an interface layer. But most of the code is in the domain and infrastructure layer. There's about 2,000 lines of code in each of those two layers. There's about 6,000 lines of code altogether in the library, but 2,000 in the domain layer and about 2,000 in the infrastructure layer. So the event sourcing mechanism that I wanted originally to reuse is the infrastructure layer. The persistence layer, which is effectively the infrastructure layer, has an event store. So that's the first object really in the infrastructure layer for the persistence. There's an event store which allows domain events to be stored and retrieved. The event store has internally its concerns are separated into an active record strategy object, which is like a manager that encapsulates the database management system. The active record strategy object has an active record class, which encapsulates stored event records. Having an active record class allows variation in the stored event schema within a particular database system. And having the active record strategy class allows variation in the database technology used to store events. The two main variants of active records are the time sequenced event and the integer sequenced event. At first there was just a stored event class that used Cassandra, and events were sequenced by timestamp. However, the alternative of sequencing by integer rather than timestamp was necessary to support optimistic concurrency control in a distributed system. And since there was still value in having some kinds of event sequenced by timestamp, it was necessary to support variation in the active record class. That was the main growing pain, figuring out that timestamps aren't really a very solid foundation for sequencing events of entities in a distributed system, a system that requires some optimistic concurrency control to maintain consistency of the entity. We can avoid events being jumbled due to time differences across the network by using a central time server, but then we introduce a single point of failure. Even with a central time server, to have robust optimistic concurrency control, we need to know if an event is the next one in a sequence, and you can't do that with timestamps. You need an integer, and the Paxos protocol, for example, is implemented in Cassandra with the if not exists feature. So if there's any contention, one thread can successfully append an event to a sequence and the others will fail and will need to refresh their state before trying again. Another point of evolution was storing events in SQL databases. I introduced the class active record strategy, which should perhaps just be called manager. There are only 2 active record strategy classes in the library at the moment, one for Cassandra, one for SQL Alchemy. I'd like to support other database services such as Amazon's DynamoDB, but I haven't done that so far. Another point of development was optimizing the queries. We don't need to search for all the events at a particular version, and coding a general index that allows for that compromises performance when there are lots of events. So actually optimizing the queries was an important thing to do. Another point of development was encryption of the domain event before it's stored, which provided for application level encryption, which was something which is required in a place I was working at. So that's the infrastructure layer, which is the original motivation, as I said. And the library is also a domain layer. The domain layer uses the event sourcing infrastructure and has DDD, domain-driven design, shaped things such as an aggregate and repository. As described in Martin Fowler's Patterns of Enterprise Application Architecture, the repository presents a dictionary-like interface. The event-sourced repository uses the given key to select events which are replayed to obtain an entity that is returned to the caller. The aggregate has, for example, a save method which writes a list of pending events to the database. I'm not entirely sure these things strictly belong in this library, but since event sourcing is a persistence mechanism for domain-driven design, it does make sense to have some DDD-shaped things that directly use the event sourcing infrastructure. Otherwise, you would have to figure that out and do it over and over if you had to do it a number of times. And if you had to figure it out on your own, you might spend time wondering if you did it in a good way. So having some classes in the library can show how it can be done. They're quite simple, so you aren't going to miss out on loads of great updates by duplicating these classes in your own code. Similarly, if you want to do things differently, perhaps, for example, distribute the mutator function across the events so they can apply themselves, there's nothing in the library that makes it difficult to do things in a different way.
And reading through the documentation, the majority of the examples are using a database as the means for storing and processing the events. But in my readings of using event sourcing, particularly for larger scale infrastructures, I've also seen a message broker used as the means of propagating those events through the system, usually in the form of Kafka. Do you have support built into the library for being able to take that approach as well, or is that just a sort of different concern from what you were trying to tackle in the library?
Yeah, I haven't supported we haven't supported Kafka yet. I haven't done any work on DynamoDB, and I'm pretty sure there's something that uses RabbitMQ, which is a message broker. But I mean, it depends what we're doing using the message broker for. I mean, if we're publishing events outside the process boundary before they're persisted, so that something else is persisting them, then there's a question: do you return before the event's persisted? Because if you just publish the event and then the application wants to carry on, then if it doesn't know that the event's been persisted, it needs to start polling for whether the event's been persisted yet before it carries on. Otherwise, you don't know quite where you're up to, I guess. So, I mean, it's complicated. You can publish the event and not save it in process, not save it synchronously, but I have never really done that. It just seems to be building your castle on sand a little bit. I think it's quite useful if you can just if you make an update to an object, that when you return, that's happening after the event's been stored, so that you know that when you go and read an object that you just created from a repository, then it's in the repository. It's not going to be appearing half a second later. It's going to be there. So I think it's a nice quality to have, to keep things in process like that and synchronous.
Yeah, from my reading, the main driver for using a message broker as the means of publishing events is in the case of a data pipeline where you're retrieving the events and then you want to be able to publish them to multiple different backing stores for different purposes, whether it's for, batch processing of reports or being able to do historical archiving, less so than if you were trying to use it in a sort of traditional web application where you want to be able to persist the events and then read them back out.
Right. So in that case, what we're doing is having dependent systems basically being updated from the application event stream. So that needs to be provided for directly, and the way that Vernon suggests to do that is with a notification log, so that downstream things can pull as a last resort. They can always pull from basically a fixed archive of the events that they can they can get the current one and then they can go back in a kind of linked way to the point where they've already seen, and then they can work forwards again, updating themselves as they go forwards. You can make that event driven by pushing events to these downstream components. But at that point, you're risking events getting out of sequence and being duplicated or being missed. So that's why I think it's important to have the pulling on the notification log thing underneath it to fall back onto. But these are very different. It's slightly different from the in-process synchronous persistence of the event, so that it's stored before the action, the command returns, which is one thing. To do it across a process involves asynchronous operations, and at that point you want to make sure. I mean, if you care, maybe you don't really care if things are out of sequence or a little bit jumbled up, or a few things are missing. If we go back to the logging case, then if my A happened appears just before B happened, and A and B aren't quasi-related, I don't really care if B shows up in the log before A or not, because it doesn't matter. But if you do care about the sequence of events, and you care to have a faithfully reproduced sequence in a different process, then you need to make sure that the first context is actually generating a contiguous sequence of events that can be followed. In other words, an application log that goes across all of the different entity sequences, because otherwise you don't know which entity sequences there are, and it's difficult to get them all out. So, for example, Cassandra, it just comes out in a big jumbled order, and you have to go through everything to see if you've missed something. So if you're wanting to do things across a process boundary, the most important aspect really, if you care about it, is to replicate faithfully the original sequence. And I don't know how to do that apart from using integer sequences, so that if you're on 5 and you don't have 4, then you're missing 4 and you need to go and get 4 before you can apply 5. If you've got timestamp 53, then you don't know if there was something that happened at timestamp 52 or 51, or whether nothing happened at those. If the last one was 50, you don't know if there was a million things that happened between those two things, or whether there was nothing at all. So that's the difficulty. It's having an integer sequence for an application that can be bigger than any one database partition can take. So you don't really want to put all of your application log in one database partition. For example, one column family in Cassandra, because you're going to fill it up, and then every time you need to do something, you're always going to be hitting the same bit of disk. It's not going to work very well. So really what you want to do is have an abstracted integer sequence running across a lot of different partitions, but in a way that gives you order 1 performance on appending to that and getting an item at a particular index. So in the library there's something called big array, which actually does this. Which gives a kind of hierarchy of arrays. So there's a sequence. Entities have a sequence in the database, and that sits in a partition. But the array sits over these sequences and gives a hierarchy of sequences, so that you can have it's kind of n to the sort of power of n number of sequences. You've got a huge space in there, more than you could possibly fill up. And each item can be accessed in order 1 time, and you can append to it you can find the end of the list very quickly, and it spans across partitions, so you don't have the problem of just hitting one disk, and you don't have the problem of worrying whether you're going to run out of numbers in your application log. And then you can, definitely an unlimited size of application stream, and then things can pull from that, from a notification log. I mean, it took a little bit of work to figure this out, to figure out what the problem actually was, and also how to solve it in a stable way. But the important thing is that if a downstream thing, you don't want to miss an event, so that if something happens in the system, it needs to be in the application log. So unless you're doing transactions, which you can't really do in Cassandra, you can't do transactions in Cassandra across different column families, so you can't have a transaction that allows you certainly to write to the application log and the aggregate sequence at the same time. So it seemed to me that you have to write to the application sequence first, so that to avoid the situation where you write the domain event and then fail to put that into the application log. You need to kind of put the application enter the domain event in the application log and then save it into the aggregate, so that if the application log writing fails, the event effectively hasn't been published. So you can't get to the situation where events are happening that aren't being notified. But it does allow the situation where an event is notified that maybe failed to write or hasn't quite finished writing into the database. So that's the kind of residual problem. And if downstream context can handle that, maybe just working slightly behind, or if they come across an entry in the application log that isn't actually stored in an aggregate stream, it can pause, or it could try again to see, or after, if 5 seconds has gone by, then it assumes that's not going to happen, or if it assumes it's going to happen, but it's important to catch up if it does actually happen, then you can code that into the downstream thing. I mean, if you had a transaction where you could write these two things together, then obviously the problem goes away, but you just can't do that with a system like Cassandra for scaling reasons. It doesn't scale so well. So that's what I've been thinking about with the downstream thing. I came across this need to have a large integer sequence and to distribute that in a way that performs across different database partitions, and I came up with something called Big Array, which seems to work quite well. Anyway, I was just trying to follow what Vern Vonen was saying in his notification log stuff and implementing domain-driven design. I think his suggestions are really good, and I tried to get things to work, and I think I did, but it's complicated, really. I think that's the thing with event sourcing, is it appears to be simple at first, but actually it turns out there's a number of subtleties which you can avoid if you don't want to have a distributed system or microservices or these things. If you just want to have a big monolith, you can just code events and get them back out when you need to present the object. But there are some more challenging aspects which you come across too.
For somebody who wants to incorporate event sourcing into an existing application, is that something that would be feasible? And if so, how would they go about doing that? And alternatively, is it something that would be more beneficial to incorporate into a greenfield project that you're starting and then use that from the beginning?
Yeah, it's a really good question. I mean, there's a choice there. Do you just do event sourcing at the beginning of a project? If a project started without event sourcing, do you just forget about event sourcing? And to keep things simple, then perhaps the answer is yes. But often the answer is that we do want to change an existing application to use event sourcing for some reason. And there's lots of ways of doing that. Someone who wants to incorporate an event sourcing design into application, it's quite a complicated topic. Of course, it's much easier to start by doing event sourcing and not switch halfway through a project. That's why I started the event sourcing project, so you can start from the beginning without any friction. If you have a legacy code base and you want to convert it, then you can start in the middle and work out. You can pick the most central object, you can write tests around it, you can figure out how it is used and decouple it from the rest of the system, and you can replace this object with an event-sourced object. This can repeat it for the next most important object until all objects have been replaced, Or you can start at the edge and work in, starting by picking off helper objects that have few dependencies and gradually working towards the most important objects. Alternatively, when things aren't coded in terms of events, you can often find lots of procedural style code. For example, save methods with calls at the bottom to update other objects, which in turn have another save method which calls other stuff, giving long chains of calls like that. This situation can be unpicked by publishing an event rather than making a call, and then having a subscriber or policy to make the call when the event happens. In this way, you can start to shadow what happens in the system with events which name what happens directly. These events can be refactored into the entity methods without disturbing any existing code. When everything that depends on the existing code is changed to depend on the events, the existing functionality can be removed. The biggest challenge gradually refactoring a large application like that will be the skills in the room, which will have been habituated on the legacy style. The length of time the code will be in a mixed state will try everybody's patience, and so perhaps a safer approach is to separate a part of the system as a service and then develop an event-sourced service that replaces the legacy service. So similar to the first approach I mentioned, you can start to introduce an interface to some objects that are used directly, or that were being used directly, so you can use them indirectly, and then you can separate those objects into a different system and call the same interface, but now the interface will be going across a process boundary or a network or something. And by separating out a little team, the people who are interested and willing to do something a little bit different can focus and work together within a sort of organisational boundary that corresponds to a system boundary, which helps to keep the group dynamics simpler, less contentious. And an even safer approach is to think forward to replacing the current system entirely, which gives opportunities for introducing event sourcing at the start of a project. But from my experience, the thing that's important is the skills in the room. I mean, people develop their skills around the work that they're doing, and if they've been developing a non-event source system, then that's what they'll be familiar with. And it's really asking a lot for those people just to leave all that behind and just start to do lots of new things and have a whole mixed bunch of code. And Eric Evans mentions this really in a discussion about microservices, where he's talking about the rough and tumble of development. So if he's using the phrase rough and tumble of development, I guess that he's had a bit of rough and tumble where people have just started to say, oh, DDD, it's a lot of hard work, event sourcing, who needs that anyway? We've got 2 scoops of Django, we know what we're doing with our ORM, we can just carry on like this. And then you can have a bit of a energy draining attrition while 2 different schools sort of slug it out within the same context boundary, within the same software development project. And it's horrible, and there's no real answer to that. There's no real way of kind of managing harmony there. People just aren't. It's not a situation that's conducive to everybody getting along, because you've got some people who've got a vision for departing from what everybody else is used to, and the story there isn't clear. And when the story isn't clear, it can be aggravating for people. And if it's aggravating for people, you're going to get the rough and tumble of development, and the rough and tumble of development is going to crowd out the more experimental, the newer, the less well-established practices. It's going to crowd out innovation. It's going to crowd out departing from how things are, which is what you need to do when you're doing development. But anyway, people do development often, or can do development by remaining in comfort zones. And one way to remain in your comfort zone is to make sure that you exclude other ways of doing things. And if you want to succeed in a situation like that, you need to separate out a little team, have an organisational boundary. You can call it a microservice, but really what you're doing is separating out a little group dynamic and nurturing that in distinction from an older way of doing things. So it depends on the skills in the room, I think, most strongly, rather than the approach itself. And if you want to develop new skills, and it's not necessarily the case that everybody's dead keen and passionately wanting to do that, it doesn't make sense to try and force it down people's throats. You have to go with the flow, and if there's people who want to do it, then you need to protect those people and encourage them to do this good work, and protect them from people who might just want to kind of stop it happening, so that their way of doing things remains known as the best and only way of doing things. I don't think this is uncommon. It's maybe a slightly unpleasant dark side of software development, but it's I think it's important. I think Eric Evans mentions it for an important reason. And these organisational distinctions are obviously essential when you're thinking about, a bunch of people developing software together.
It's always interesting to bring in the people context of technical problems because they are all too often overlooked in the common discourse when trying to figure out how to build our technologies and build our software, because ultimately all software is built to serve the purposes of the humans that use it. When you have an event sourcing application that has been in operation for a while, inevitably you're going to need to change the schema and sort of content of the data structures for those different events. So I'm wondering how that manifests in an event sourcing application, and in particular how you would account for that when you're reconstructing present state from the beginning of an object's event sequence.
Yeah, it's a really good question, and it's a difficult question. And so there's a really good paper called "The Dark Side of Event Sourcing," which I hope they mean event sourcing in general and not this project. For migration of immutable events, that paper outlines 5 strategies that are available. So multiple versions, that's one strategy. Upcasting is another strategy. Lazy transformation is the third one. In-place transformation is the fourth. And the fifth one is copy and transformation. So the last approach allows you to rewrite events into a new event store. It's not an essentially difficult problem, but it does require some thought. And like with many other things, mixing approaches might not be optimal. So if we think about it, what we've got is stored events. And if the model changes, we could change the model in different ways. So we could change the model by changing the events which constitute the objects, or we could change the model by augmenting those events with new versions of those events. So we could start to record which version of the event it was, or if we just had completely different events and it doesn't really make sense to start to version them because you changed the name of something, or you merged events, or you made a distinction with an event between 2 different events, then at some point versioning isn't really going to stretch to it, and you'd want to just kind of rewrite your history, which gives us the transformation thing. So there's the versioning, and there's kind of upcasting, which is where you go, oh, well, this event is how we used to do it in the past, and then whenever we see this one, we change it into this other thing, which is the new way of looking at it, and then we apply that event. So you can kind of upcast. Lazy transformation is where if you hit on some events which are old, then that's the time when you rewrite them. So you don't just have a batch job and take your system offline and rework everything and then switch it all back on and everything's been transformed. You do it in a lazy way. And then in place transformation and copy transformation. So, in place would be where you just rewrite the events and the event store as you have it. And then copy transformation would be where you read out the events in your event store and then change them and write the changed events into a new store, and then presumably get your system to use that new store. So there's different ways of doing it, but you just need to remember that there's events, and if you want to change those events, you just need to pick a way of making sure that the system is picking up new events somehow. So there's different ways of going from A to B. You can assume that you can rewrite A to B as soon as you pick up A, but if that's complicated, then you might want to just rewrite the whole event stream and then carry on with a completely transformed situation. But that's all you have to do, because there's nothing else other than the events.
Yeah, I can see that, at least from some perspective, transforming the model and representation of the event structure is simpler in an event-sourced application than it is in a relational database, for instance, where you need to transform the state of everything at once because you're changing this table structure. Whereas with event sourcing, you can, as you said, just change the way that the events are written out, and then you can sort of backport that to all of the previous events by replaying them into the new schema. And what are some of the most interesting uses of event sourcing that you've seen, whether in particular implementations with your library or just the pattern in general?
So I was involved in a startup in East London like 3 years ago, and it was just a thoroughly event-driven domain. It was a little AI, it was a little smart application which sat over all your cloud services, so email and calendar and notes and documents and things, calendar, and it would give you a timeline of what's happened across all of your stuff, so you could see calendar being changed in amongst emails and documents and whatnot. And then it would give you smart recommendations. So the idea was that it would be able to kind of infer from your meetings the documents which, pertain to the discussions with the people who are going to the meeting. So it would then be able to kind of give you all of the stuff for that meeting all together just before the meeting happened. And it would be able to do other smart recommendations and other stuff over the top of all of these events coming out of these cloud services. So it was a matter of having a polymorphic, event-sourced file model that all of the different objects were then kind of duplicated into, or the data we pull out of these cloud services was considered, everything was a file, but different kinds of files. So we had a little polymorphic event source model for files of different kinds. So we were picking up on streams of events and then streaming events into the data science stuff and other bits and pieces into views, so that when you hit your app, everything just came up straight away. The timeline didn't have to go through all the events to figure out what was it. There was a timeline view data which was already being updated, and you just went and you got your timeline instantly, and the recommendations were kind of similar. So that's when I started doing the event sourcing stuff. It just seemed like a really good fit, and it was, and we got it working quite quickly, and it worked, and it was quite interesting to see how good a fit it was with all of the cloud services, how they essentially were just giving you, streams of differences or streams of events, depending on quite how it was styled. And you could pick up on those things and update stuff based on them and code those as domain events. And it was really neat and very understandable and worked quite well. But it's just that I started doing it with timestamp-based events, which actually there's a CTO there, he really wanted timestamps, so that was good. It just turns out that timestamps didn't really get you all the way there. That was very interesting. It was a startup in East London. To kind of go to the other end of the scale, another project was in a large corporation, and they had a need to have great scale. I mean, the domain wasn't the most kind of technically complicated domains. I can't really talk about it because it was an NDA. It was under an NDA. But it was massive, they wanted huge scale, bigger than, there's a kind of classic situation that was referred to where, everything happens in just a few minutes rather than people having to kind of hang on to the website for half an hour and then maybe not getting what they wanted. And it was a big high scale event based system, and we scaled it up so it actually worked at scale, on cloud infrastructure. It was kind of a huge project, really. And that was interesting because of the scale, because of, the size of the corporation that was doing this thing and the ambition that they had for this system. So that was interesting. The first one was interesting for the architectural aspect of it. It was the first event sourcing project I did. And then the other project that I mentioned was kind of doing that at scale, in an established corporation rather than a little startup. So those are the two most interesting uses of event sourcing that I've seen.
And looking forward, what are some of the features or improvements that you have planned for the future of your library?
Yeah, well, thanks for asking. It's kind of complete in that there's application level encryption, there's different types of events, there's optimistic concurrency control, there's some DDD classes, it's well factored, it's got 100% test coverage. So, the things that I've got in mind to do on it are better documentation. So there's a GitHub issue about that. So there's a little, bunch of enthusiasts and discussed this with, and it seems that the documentation wasn't quite as good as it could be. There was a huge README file, and I restructured that into some Sphinx documentation, and I think I didn't quite cut it in the right way. So the new documentation will have a much clearer distinction between the infrastructure layer, the kind of internal event-sourced persistent stuff, the original motivation for the library, just kind of cover that, and then separately to that introduce the DDD classes which use that stuff. At the moment, there's the DDD classes are kind of used in a repetitious way to give examples of the different ways in which the internal kind of persistence mechanism can be used, and it's not optimal. I've said I'm going to rewrite it along better lines. So that's one thing. And the other thing is broader support for popular database services. So you mentioned Kafka. I mentioned DynamoDB. So there's some work to be done there. I don't know exactly when I'm going to do it, but I think it's important to do. The event migration, the better support for that. I don't know if there's code which can help with that, or whether it's just understanding the different approaches and how. So maybe a bit of documentation. I don't know whether code which would help there. I don't know. And then better examples. So on the Slack channel, we've been talking about better examples. So there's two little projects people have started to use the event sourcing, a little to-do thing, and then another application that someone wanted to write. So if those, I don't think anything's happened in those last couple of weeks, but that would be really nice if we had some better examples. And then, looking at the technicalities, the thing which I haven't quite satisfied myself about is this propagation of events from one context to another. The problem seems to have two parts. If you want an integer sequence for a single application, you need to find a way that works across database partitions. And if you want entity event sequences and an application notification sequence, you don't have transactions, and you need to find a way to make sure there is a notification for each domain event. The first problem I solved, as I mentioned before, with a structure I called big array. The second problem I think I nearly solved, but the residual issue, as I mentioned before, disambiguating when there is a notification but not a domain event, whether the domain event is appearing or will never appear. If that's something downstream context can cope with, then I've sort of solved the second problem too. But that needs some finishing off stuff that needs to be done there. The notification log, there's some the kind of JSON API stuff and interface layer for that, and it's well tested and it works. It's just that I don't feel entirely satisfied with it perhaps for no reasons at all. Maybe I just need to leave it for a little bit and come back to it and talk about it with some people. But there's just an aspect. I think internally within a single process, it's largely complete. But there's just there's documenting it in a better way. I think that's important. And then there's this idea of propagating events across a context, which works. But if it needs to be really robust, then I think we've got that. But I'm not entirely convinced. So there's just an outstanding kind of worry, perhaps. It's a real concern, or whether it's just a worry, I'm not quite sure. But propagating events from one context to another is still something I'm thinking about. I don't think it's actually completely done, but internally it's kind of done.
All right. Well, are there any other topics or questions that you think we should cover before we start to close out the show?
No, I think your questions have been really excellent and demonstrate a very good understanding of this particular topic. I mean, I don't consider myself as a kind of expert in event sourcing. I've just tried to figure it out and write some code which would be useful for me and perhaps others, going forward, something I can use to accumulate things that I've learnt and maybe show the limitations of my understanding to other people so they can help me learn things that I just got stuck on. That is the idea of it, really, anyway. So maybe there's a completely different take on this that I kind of missed. There's a different way of doing it which I've missed. But I think I've tried to think about it exhaustively, and I've tried to do my best on it. I think your questions really cover the scope that I've discovered in doing this, and I don't know what you've missed. I'm not sure you have missed anything at all.
Sure. Yeah, it's definitely useful to have a concrete implementation to use as a starting point for any conversation, because then everybody has common ground to work from, as opposed to just trying to relate their own unique understanding of a particular problem domain. They can look specifically at the ways that it's implemented in the code and then work from there. So for anybody who wants to get in touch with you or follow the work that you're up to, I'll have you add your preferred contact information to the show notes. And with that, I'll move us to the pick. And my pick this week is a conference presentation by Corey Quinn called Heresy in the Church of Docker. And it's just a really well put together and humorous look at the sort of hype that has come up around Docker and how it will be the be-all, end-all of our deployment problems, and just talking about how it's great for development, but how it still has a lot of operational concerns that it doesn't address. And so just looking at the ways that the common perception of it as being a panacea for our deployment solutions hasn't quite come to pass. So it's definitely entertaining and educational, and I highly recommend anybody who's interested in Docker take a look at that. And with that, I'll pass it to you, John. Do you have any picks for us this week?
Well, I mean, the thing I've actually been working on for the last few weeks is something called Quant DSL, which is a domain-specific language for quant analytics. And finance is quite an important thing. If you want to do some energy infrastructure, then you need to get the finance around that. So you need to kind of price these things. And there's loads of, groups doing energy stuff. And they all seem to buy these tools that cost hundreds of thousands of pounds, these proprietary software modelling tools. So for the last maybe 5 or 6 years, with a friend of mine from Oxford who's a PhD in this stuff, we've been developing some open source maths codes for quant analytics in finance and trading, which are really, it's really quite excellent stuff. I mean, I don't mean to blow my own trumpet. They leaded a lot of the maths, and I've been working on the domain-specific language kind of aspects of it. But we can price power stations and gas storage facilities. You can do correlated models between, different markets with multi-factor. I mean, it's really quite advanced stuff, and there's nothing else really like it in the open source space. There's just a lot of proprietary tools. So, trying to disrupt that kind of, proprietary fintech modeling thing is... I think it's quite interesting. I mean, if you look at the energy infrastructure in the UK, you've had the government having, kind of agreeing to quite shockingly high strike prices for nuclear power plants, when if you had some, where there's nobody can kind of question these things because there's no really ability to turn the handle on the maths. But with a system like this, you can start to do valuations. Internally within energy companies at the moment, what a lot of people do is just knock something up quite quickly in a spreadsheet or in some kind of ad hoc Python code or something, and then it takes a little while, and then obviously that can't go into production if a deal goes through. So the structures try and knock things up, and then there's a kind of organizational boundary to kind of getting these things into production. If you had a domain-specific language, then you could just easily experiment with different structures. And then if something happens, you can just easily just kind of put that into production. So it's I think it's a really nice, clever project, and I've been working on it for the last few weeks. I've been working on it quite a lot recently, and trying to get something going with that. So it's not really a pick, but it's the thing that I've been really kind of focusing on the last few weeks.
Yeah, that definitely sounds interesting. So thank you for sharing that. And thank you for taking the time out of your day to join me and talk about the work you've been doing with event sourcing and the library, for being able to try and codify that. It's definitely something that I find interesting, and I am sure that other members of my audience will as well. And definitely seems like you've done a good job with it. So thank you for that. And I hope you enjoy the rest of your day.
Well, thank you, Tobias, having approached me about this. It's very encouraging and exciting, and I hope that I hope you have a great day in Boston today.